Hi and welcome to today's video. Today we're going to be looking at osmosis. Now osmosis is just an example of diffusion, and diffusion is the movement of molecules down a concentration gradient, and that's from an area of high concentration to an area of low concentration. Now simple diffusion is just an example of passive transport in that it requires no energy input from the cell. Okay, so osmosis, what does that actually mean? It's defined as the movement of water molecules across a partially permeable membrane from an area of high concentration to an area of low concentration. And what partially permeable means is just it's a barrier, and it only allows certain types of molecules to pass through. So within this example, we've got water on one side over here, and we've got a sugar solution on the other side. And what actually happens is the water is able to cross over this barrier because it's small enough. However, the sugar molecules, as you can see, are too large to pass through into the opposite direction. So therefore we have a net flow of water moving from left to right. Okay, so you can actually demonstrate how osmosis works by using a very simple practical. All you need is an egg, some vinegar and a couple of days patience, and what you're eventually left with is an egg without a shell. Now the rubber egg, as a few people like to call it, is a good demonstration of a very basic cell. So you've got the nucleus, which is obviously the yolk, you've got the albumin, and then you've got the membrane itself. Now the reason why it grows in size when you place it within the vinegar is because the albumin is about 90% water. So what happens is that the water from the acid enters the cell, and that's why the cell or the egg cell increases. Once it's reached equilibrium, then we say that it's reached an isotonic state. That's basically where the net flow of water is equal in both directions. If we were to place this egg cell into, for example, a pure water solution, something like distilled water, then we'd see a net flow of water going into the cell. Therefore, the egg would gain in weight and size. If we were to place the egg into a sugar solution, what we'd expect to see is the net flow of water move out of the cell. So water would actually leave the cell, and therefore the cell would start to shrink. Finally, the movement of water needs to be closely monitored and controlled by both plants and animals. This is done through a process known as osmoregulation. So for example, here we've got a red blood cell, and you can see in an isotonic solution it keeps its shape. However, within a hypertonic solution it loses water and shrivels up, while with a hypertonic solution it takes on board water until it bursts. Now, osmoregulation is just one of many homeostatic systems which are designed to keep a stable internal environment. It's carried out in animals through the skin and the kidneys, and in plants it's carried out by the stomata.